P2, energy transfer by heating. I want to talk through two concepts of the three. The specific heat capacity will be on a separate video. I want to look first at conduction, and this is how heat energy moves through solids. We've got two different solids here. One is copper, a metal, and one is plastic. And I want to talk about how the heat will transfer through those materials. If we were to heat our copper at this corner here, all of these atoms that make up the copper, this one will start to vibrate as the thermal heat energy transfers to kinetic energy here. This one starts to vibrate because all of these are close together and touching. The vibrations from here pass on to the next atom, which passes on to the next atom, and it keeps going. So those vibrations pass all the way through the material, and all of it gets hot because copper is a good conductor, which means it's very good at passing the heat energy through the material as kinetic energy, and it makes the whole thing hot. So the whole thing passes the energy through easily. Okay, so we can summarize here. The atoms vibrate when they're heated. They bump into each other, and this causes them to pass those vibrations on. So the heat energy passes through good conductors quickly. With plastic, it's made from atoms very similar to copper, but they're different in as much as when we heat them up in this corner here, the vibrations don't pass on very much. These vibrations here will pass through very, very slowly. So plastic is a poor conductor. In fact, we call these poor conductors insulators. Okay, so if we were to hold our piece of copper here while heating up in this corner, eventually, quite quickly, this end of the copper gets hot and will burn our hand. If we held the plastic here and we heat it up in the corner, we find that this bit doesn't get hot because the vibrations don't pass through. So good conductors are metals, and poor conductors tend to be non-metal materials like plastics. Wood is another one. Textiles, cotton, wool, they're all good insulators. They don't pass heat energy through very easily. Okay, so that's the theory of conduction, how heat passes through solids. And different solids will allow heat energy to pass through at different speeds. That can be used, particularly here, the insulators, when we talk about buildings and how we try to stop heat escaping from buildings. It's really important for lots of reasons. Cost is one, we can save money, but also it's good for the environment because we're using less energy, which means we're burning less fossil fuels. How can we do it? There are four main ways that we would look at. One is cavity wall insulation. Another is through the roof here using glass fibre, double glazing, and floor coverings like carpet. Okay, so we can lose heat energy through the walls, through the roof, through windows, and through the floor. And these are four examples of how we would reduce that heat energy loss. Which means that carpet, glass fibre and cavity wall insulation and double glazing are all good insulators or insulating materials. Less so with double glazing, it's a gap between two panes of glass which is filled with an inert gas which is not very good at conducting heat energy. Okay, glass fibre is a good insulator, carpet is a good insulator, and cavity wall insulation, if you can imagine the little balls inside a beanbag, those tiny little polystyrene balls, if you filled the gap between the two layers of bricks that make the walls of modern houses, that will fill full of those tiny little balls, and that's a really good insulator. It stops the heat energy passing through the walls. Now, you would also be expected to do some simple calculations, and what we're looking at here is payback time. So payback time is the important thing, and usually in these questions, well always in these questions, they give you information, and it's usually in a table, and they'd expect you to work out the payback time. So the question might be, which is the best or most cost-effective type of insulation? Is it cavity wall insulation or is it double glazing? And they will give you some information. So they will tell you the cost. So to get the wall filled with those polystyrene balls will cost £100. To have a window fitted, double glazed window, £500. Okay, I've just made up the values, and they're not important in themselves. The saving, they have to tell you this, so you'll save £10 every month if you have the cavity wall insulation. You'll save more money per month if you get the double glazing, okay, which sounds really good, okay? So we're saving more money per month if we get the double glazing. However, the payback time is how long it takes for the original cost to be paid back from the savings we make. And we do that by taking the cost and dividing it by the savings. So here 100 divided by 10 is 10 months. If we take the £500 cost of double glazing and we divide that by the savings, which is £15 a month, that's 33.3 months. So which one will save us the most money? It is double glazing, but which one has the shortest payback time is cavity wall insulation.